Today, we are going to be talking about rational numbers. Let's first define what a rational number is. A rational number is any number that can be written as a over b, where a and b are integers and b is not equal to 0. Wow, that seems really confusing when I first read it, but let's break this down. In other words, a rational number is a number that can be written as a fraction as well, and the numerator is made up of an integer and the denominator is made up of an integer, but the denominator will never be 0. Let's look at some examples. Using that definition, let's look at these three numbers. And let's decide which of them could be rational. Well, number 1 says 57 hundredths. Can I write that as a fraction? Number 2 says 3 1/2. Can I change that number to a fraction? And then the third one is 42. Can I write that as a fraction? Why don't you take a minute to scrap some notes down and see if you can change all three of these into fractions. The one that can't be changed into a fraction is obviously not rational. Alrighty, have you thought about which numbers here are rational? Well, they all are. They actually all can be rewritten as fractions. And let's take a look. So 57 hundredths can be written as decimal point 57 or 57 over 100. Therefore, the numerator is an integer and the denominator is an integer as well. Question 2 is 3 1/2, which I can easily change that to a decimal 3.5. Or 3 5/10, which turns out to be 35 tenths. And 35 tenths is written as a fraction. It's an improper fraction because the numerator is much bigger than the denominator. But we can call this a rational number because the numerator is an integer and the denominator is an integer. And question 3 says negative 42. Well, negative 42. What number, when I divide by negative 42, gives me negative 42? Well, the answer is 1. So I can rewrite negative 42 as negative 42 over 1, and it's still equivalent to negative 42, but I've written it in fraction form. Therefore, if I can write a number in fraction form, like all of these three, then I have a rational number. Here's another example. Is 1.5 a rational number? Well, it is, because 1.5 is the same as saying 1 1/2, or I could write it as 3 halves, 3 over 2, which is in fraction form. And if you remember, if I have 1.5, whoops, that's equivalent to 1 5/10. And 1 5/10 is a mixed number now. And a mixed number, I can continue this and write it as an improper fraction, or that would be 15 tenths. And I can leave it at 15 tenths and still prove that it's a rational number. But we always like to simplify our fractions. So 15 tenths, I can think about a common factor. And a common factor that jumps out at me is 5. Now, if I use any common factor, I'll have to keep simplifying to lowest terms. But if I use the greatest common factor, it will simplify to the lowest terms in one step. So 15 divided by 5 is 3. And 10 divided by 5 is 2. So 1.5 can be written as 3 halves. And again, this is in fraction form. The numerator is an integer and the denominator is an integer. So 1.5 is a rational number. We often use Venn diagrams to categorize items. Scientists categorize different animals, and mathematicians can categorize numbers. So let's look at this Venn diagram. Okay, we have rational numbers, integers, and whole numbers. Now, rational numbers include integers and whole numbers because in order to be a rational number, the numerator and denominator both have to be integers. And integers include whole numbers because all integers, negative or positive, are whole numbers. Here is a great screen to constantly review on how to classify a rational number in a Venn diagram. And you can follow all the arrows. So when you're given a number, if it's a whole number, then you can place it in the whole number set. But if it's not a whole number, you can then ask yourself, well, is it an integer? And if it is an integer, it can be placed in the integer set, which is outside the whole numbers. And if it's not an integer, then you can place it in the rational number set outside of the integer set. Okay, let's see if you can answer this question on your own. Why don't you press pause on the video and try to figure out which one of the following numbers is not rational. Okay, let's go through each one. Let's look at A. A says 7/16. Well, I know that 7 is an integer, and I know that 16 is an integer. 16 is the denominator, and it's not 0. So therefore, this must be a rational number. Let's look at C. C is 7/1. 7/1 is equivalent to 7 wholes. 7 wholes is written as 7/1. The numerator is an integer, the denominator is an integer, and the denominator is not 0. So it hits all of the items for rational numbers. Therefore it is. Let's look at B. B is 7/0. 7 divided by 0. Well, that doesn't give me 7. It gives me a whole different number, which is 0. And I know that 7 is an integer, the numerator, but the denominator is 0. And I know it can't be rational if the denominator is 0. So right away, I know this is not rational. But let's keep going. And then letter D is 0.7, which is equivalent to 7/10. 7/10 is written in fraction form. 7/10. 7 is a integer, and 10 is an integer. So this is a rational number. So therefore, it must be B. B is not rational. And we call not rational numbers irrational numbers. All right, so let's summarize this lesson about rational numbers. Rational numbers are numbers that can be represented as fractions. And always keep in mind that they include integers and whole numbers where the denominator is not 0. And those numbers that are not rational, if you cannot put it in fraction form where the numerator and denominator integers and whole numbers, then it's called irrational. And a good example of an irrational number would be pi, or a decimal that repeats without a pattern. So if it just goes on and on and on and on, no pattern at all, then those are irrational numbers. Hope this video has helped you learn a little bit about rational numbers, and remember to watch it as often as you like, especially when you need to remember what a rational number is.